welcome students, welcome to TKG Physics classes. So today our topic, that is electrostatic potential energy, and which is in chapter 2, that is electrostatic potential and capacitance. In this lecture we will learn electrostatic potential energy, that is the definition of electrostatic potential energy. After that we calculate electrostatic potential energy for various point charge system. Suppose we calculate electrostatic potential energy for 2-point charge system, then we calculate electrostatic potential energy for 3-point charge system, 4-point charge system, and finally we calculate electrostatic potential energy for n number of point charge system with some numericals. So first of all we have to learn what is electrostatic potential energy. So what is electrostatic potential energy? The electrostatic potential energy associated to the point charges, number of point charges with respect to its position. Suppose there are two similar point charge system which are at infinite distance apart. So their potential energy is zero. Question is why? Because there is no work has to be done in moving a charge at infinity to the other point. But if the two point charges, the two similar point charges are brought closer to each other, then the potential energy has a positive value, because in this case work have to be done against this electrostatic force of repulsion. Now question is why force of repulsion? Because the charges are similar, so the nature of force, that is repulsive, and this amount of work done is stored as a form of electrostatic potential energy. As you know, the electrostatic force which is conservative in nature. Clear? So what is the definition of electrostatic potential energy? That is, electrostatic potential energy for a number of point charge system is defined as, may be defined as the amount of work done in assembling a point charge, in assembling a n number of point charges at their locations, in bringing it from infinity. Clear? Now we have to calculate the theory. That is, at first we have to calculate electric potential energy for n number, for 2-point charge system. For 2-point charges. Why 2? Why not 1-point charge system? For 1-point charge system, the amount of work done result is 0. That's why electrostatic potential energy for first case, that is 2-point charge system. Suppose there is a point charge Q1 at point P1. So in this case, the amount of work done is 0 because there is no electric field yet. This amount of charge is moving at infinity to point P1. So at point P1 there is no electric field yet. So first case, the amount of work done, that is W1, result is 0. Clear? Now suppose we consider another point P2, and the separation between P1 and P2, that is R12. Clear? Now what will be the electric potential at point P2? Write it down. The electric potential at P2 due to which charge? This Q1. Due to Q1, that is, expression is V1, and you know the formula for a point charge system. The formula, that is 1 by 4 pi epsilon naught. The amount of charge, that is Q1 here, that is Q1 by the separation, and the separation between P1 and P2, which is R12. So this expression will be V1 is equal to 1 by 4 pi epsilon naught Q1 by R12. This is the electric potential at point P2 due to this charge Q1. Now suppose there is another charge, that is charge Q2, which is placed at infinity. at infinity. Clear? Now in moving this amount of charge from infinity to point P2, what we have to done? We have to do some work done. Clear? So in moving this charge from infinity to point P2, we have to do amount of work done, and you know the formula of work done, that is electric potential formula, W by test charge. So work done, that is equal to charge into V, that is work done is equal to test charge into electric potential. So the amount of work done, that is W2, and the formula is test charge. Now here test charge, that is Q2. Here Q2 is moving from infinity to point P2. So Q2 into the potential at point P2, and the potential at point P2, which is represented by V1. So Q2 into V1. Now putting the value, that is 1 by 4 pi epsilon naught Q1 by R12, Q1 by R12, and there is Q2. So Q1, Q2 by R12. This is the amount of work done, which is represented by W2, and this amount of work done, that is in moving a test charge Q2 from infinity to point P2. And for single point charge, which is taken from infinity at point P1, Q1, the amount of work done result is 0. So what will be the total amount of work done? That is total work done, you know the formula, that is W is equal to W1 plus W2. Write it down, that is W1 0 and W2 expression 1 by 4 pi epsilon naught, that is Q1 Q2 by R12. Clear? Now this amount of work done is stored as a form of electrostatic potential energy, which is represented by symbol capital U. So electrostatic potential energy for this two-point charge system, this two charge point system, and the expression, that is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12. So this is the final expression. The final expression, electrostatic potential energy for two charges, 2 point charges, 2 point charges. Now we have to calculate electrostatic potential energy for 3 point charge system. So write it down. For this one will be 3 point charges. There is charge 1, there is charge Q2, and there will be another charge we have to take in from infinity to at a point. Suppose we have to bringing a charge Q3 at point P3. Q3, this is Q3 at point P3. This is the point P3. So for single point charge, amount of work done W1, that is 0. Now in bringing Q2 at infinity point P2, the amount of work done W2, that is this expression. Now at first you calculate electric potential at point P3. Electric potential at point P3 due to Q1 and Q2. So what will be the expression? Electric potential at point P3, electric potential at P3 due to Q1, write it down at first. Suppose this separation P1 and P3, which is represented by R13. So what will be the expression? That is, if you write it down, that is V2. Okay, so formula will be 1 by 4 pi epsilon naught, the amount of charge, that is Q1, and the separation, that is R13. Clear? This is the electric potential at point P3 due to Q1. Then write it down, electric potential at point P3 due to Q2, which is represented by, suppose, V3. Write it down, this is P3 and this separation, suppose this is 3 and this is 2, so which is represent R23, and the expression will be same, 1 by 4 pi epsilon naught, the amount of charge here, that is Q2 not Q1, divided by this separation, that is R23. Clear? So total potential at point P3, that is V2 plus V3. Now we have to calculate the amount of work done in bringing another charge, which is Q3 from infinity at point P3. So what will be the amount of work done? You know, that is the amount of work done, W3 is equal to formula, that is test charge into potential. So test charge, that means Q3, and into potential, that means potential at point P3, and potential at point P3 for Q1 is V2, potential at point P3 for Q2, that is V3. So total potential V2 plus V3. Clear? Now putting the value, that is 1 by 4 pi epsilon naught common. For V2, that there is Q1 and there is Q3, so this one will be Q1 Q3 by separation R13 plus of, for V3 there is Q2, that is Q2, and outside there is Q3, that is Q2 Q3 divided by R23. So this is the expression of, this is the value of amount of work done in bringing a charge Q3 from infinity to point P3. Clear? So amount of work done in bringing charge Q1 at point P1, that is 0. Now amount of work done in bringing a charge Q2 at point P2, which is expression this one, that is also W2, 1 by 4 pi epsilon naught Q1 Q2 by R12, and the amount of work done in bringing a charge Q3 at point P3, that is W3. So what will be the total amount of work done? Just summation, that is total amount of work done, total amount of work done, W is equal to W1 plus W2 plus W3, W1 0, W2 expression, W1 0, W2 1 by 4 pi epsilon naught Q1 Q2 by R12 plus W3, and this is the expression 1 by 4 pi epsilon naught Q1 Q3 by R13 plus, for there is another part, 1 by 4 pi epsilon naught Q2 Q3 divided by R23. So this is the total amount of work done for 3 point charges. Clear? Similarly, there is a 4 point charges, you have to calculate amount of work done. So what will be the final result? That is electrostatic potential energy for n number of point charges. So write it down. The electrostatic potential energy for n number of point charges. Electric potential in, okay, write it down. That is electrostatic potential energy for n point charges. that is U is equal to 1 by 4 pi epsilon naught common summation, and at first you write all pairs Qi Qj by Rij. What is Ij? Ij represent indices. If we simplify it, this expression will be 1 by 4 pi epsilon naught summation, if I is equal to 1 to n, and another summation, that is j is equal to 1 to n, but there is a condition, that is I not equal to j, and there is a formula, that is Qi by Qj divided by Rij. So this is the final expression, the final form of electrostatic potential energy for n number of point charge system. Not clear? Yes, not clear. Okay, there will be half. Why half? Why j or I not equal to j? Okay, let's take one example. Suppose I equal to 1 and there is a condition, that is I not equal to j. That means j starting from 2, not 1, because I 1. So what will be the formula? That is Qi, that is Q1, Qj, that means j starting with 2. So Q2 by Rij, that is R12, right? Now, if I consider j is equal to 1, then what will be the minimum, what will be the starting value of I? I will be 1. No, there is a condition, I not is equal to j. When j is equal to 1, I will be 2, 3, 4 up to n, but not 1. So suppose I equal to 1, j equal to 1 and I equal to 2, then what will be the formula? That is Qi, that is Q2, Qj, that is here j is equal to 1 by Rij, that is R21. You just check Q1 by Q2 by R12, and that is Q1 by Q2, or you may call Q2 by Q1 by R21. There is two terms, same exactly, but Q1 by Q2, the product of Q1 by Q2 will be single term only. That's why there is a this part, half. So this is the expression, that is U is equal to half into 1 by 4 pi epsilon naught summation, that is I, which is starting from 1 to n, and another sum index, that is j, which is starting from 1 to n, and there is a condition, that is I not is equal to j, Qi Qj by Rij. Clear? So electrostatic potential energy for for a single point charge, that is 0. Electrostatic potential energy for a 2 point charge system, that is 1 by 4 pi epsilon naught Q1 Q2 by R12. And electrostatic potential energy for 3 point charge system, that is 1 by 4 pi epsilon naught Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. And finally, for electrostatic potential for n number of point charge system, this is the formula. So this is all about theory part. Okay. Now let's take some examples. Okay. Suppose problem 1. In the problem 1 given Q, there is another Q and there is another Q. They form an equilateral triangle. And this triangle has separation A. And the question is, you have to calculate electrostatic potential energy for this configuration. What is the rules? Here is charge Q and here is charge Q, and the separation is A. And you know, if there is a charge Q1 and there is charge Q2 and separation is R12, what is the electrostatic potential energy? There is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12. This is the formula for 2 point charges. So if there is a 2 charges Q1 and Q2 and the separation is R, so energy will be 1 by 4 pi epsilon naught Q, that is Q square, by the separation, that is A. Clear? Now consider this system. There is a charge Q, there is a charge Q, and the separation is R. And so similarly for this case the expression will be same. Clear? And for this case Q, separation is R, so this expression will be same. So what will be the total potential energy? The total potential energy U, that is 1 by 4 pi epsilon naught Q by A plus 1 by 4 pi epsilon naught Q by A plus, there is another part, 1 by 4 pi epsilon naught Q by A. So the total expression will be 3 into 1 by 4 pi epsilon naught Q square by A. Clear? Suppose there is a form magnitude value Q given 6 into 10 to the power minus 6 Coulomb and A given 10 centimeter. So 10 centimeter, you have to convert it meter, okay, just divided by 100, that is 1 by 10, that is 0.1 meter. Now putting the value 3 into 1 by 4 pi epsilon, that is 9 into 10 to the power 9 Q square, that is this expression, 6 into 10 to the power minus 6 the whole square, divided by separation, that is 0.1, and solve it, and then this one will be the answer. So this is the way out, this is the way for calculating electrostatic potential energy. Now let's take another example. Suppose there is a given question, we are given configuration, there is 4 charges, there is 4 charges following 4 charges Q, and another Q are placed at the corners of a square, and the separation given, suppose A, and you have to calculate electrostatic potential for this configuration. So what will be the way out? Same for 2 charges Q and Q, separation A. So for 2 charges formula is 1 by 4 pi epsilon naught Q by A. So 1 system, 2 system, 3 system, 4 system. Clear? And there is another 2 system, that is this diagonal Q and Q, and this part Q and Q. So what is the total terms? This one 1, 2, 3, 4, 5, and this part 6. So what is the final form? That is U is equal to 1 by 4 pi epsilon naught for this part. Okay, write it down, Q1, Q2, Q3, Q4. So for Q1 and Q2, there is 1 by 4 pi epsilon naught Q1, Q2 by A. Clear? Now for Q2, Q3, that is 1 by 4 pi epsilon naught Q2, Q3 divided by A. Now Q3, Q4, that is 1 by 4 pi epsilon naught Q3, Q4 divided by A. Now Q4, Q1, that is 1 by 4 pi epsilon naught Q4, Q1 divided by A, plus this diagonal parts Q1 and Q3, that is 1 by 4 pi epsilon naught Q1, Q3, and what is the separation here? A, not, this is the diagonal part, A. So this part will be root under A square plus A square, clear? That is 2A square, that is root 2A. that is root 2a plus, for this case, that is Q4 and Q2, that is 1 by 4 pi epsilon naught Q4 Q2, and this is also diagonal, so result is root 2a. So total terms, that is 6. 1, 2, 3, 4, 5 and 6. So this is the final form of electrostatic potential energy for this configuration, and this is the way for solving electrostatic potential energy for these types of configuration. So this is all about electrostatic potential energy. This is how to calculate electrostatic potential energy for a different configuration. And you see the theory, that is theory part for electrostatic potential energy for 2-point charge system, 3-point charge system, and similarly for a number of point charge system. So this is all about this lecture. Stay tuned and thank you. Next lecture will be coming soon.